Why hello once again, my fellow space cadets. As always, this is Dr. Phineas Cortex at your service. If you're just joining us from the last entry, we have finished our trek across the mighty solar system. And right now, as I orbit around the Earth's atmosphere, as I currently am right now in the USS Carolina, I'm doing some further studies on space and whatnot. So, if you wish, you can join me as you always have. Now, before we get any further, I have another question of the day. Let's go ahead and answer it. Now, this one comes from Anna, and she asks, "Dear Dr. Cortex, why do astronauts wear spacesuits?" Well, although that question may appear straightforward and obvious to some, there are quite a few explanations as to why astronauts wear spacesuits. The first, obviously, is to keep them breathing and to provide oxygen for them in the vacuum of space. Second reason is actually to regulate temperature. See, space and several planets outside of Earth are relatively extreme when it comes to temperatures. Whether it is too hot or too cold, astronauts really need these spacesuits to keep their temperature regulated. And the third thing, obviously, is to protect them from the forces of space, including the harsh rays of sunlight that spew out of the sun. But anyhow, that's a good question, I think. And like myself, we astronauts really do need these spacesuits at times. Fortunately, we have these wonderful spaceships to keep us safe when we're not out there in space. But let's get right into things, shall we? We've really discussed all of the planets of the solar system, including our moon and Pluto. But what really is the lifeblood of the system? If you guessed the sun, then you would be 100% correct. So, let's get right into it, shall we? Now, if you can see right here, the sun is a really, really big star. As if you can see right here, my lovely little illustration of the sun. If you can see that dot right there, can you see that? That is Jupiter. Yes, the largest planet, 1,000 times bigger than Earth, is 1,000 times smaller than the sun. My word, the king of the planets, right there. A mouse compared to the sun. As a matter of fact, 1,000,000 Earths could fit inside this behemoth of the sun. Now, although the sun itself may be large, it behaves like a planet when compared to the vastness of the Milky Way galaxy itself. As a matter of fact, it revolves around the center of the galaxy, like a planet would. About the distance from the center of the Milky Way galaxy to the sun, it's about 30,000 light years, so we're not talking about small distances this time. Obviously, the number of planets that, the sun has in its huge, huge gravitational pull is 9, including Pluto. As a matter of fact, the sun itself rotates like a planet would. It takes about 25 Earth days for it to rotate. But when really looking at the revolution period of the sun, it actually takes the sun, along with the entire solar system itself, 225 million years just to make one full revolution around the Milky Way, based on what scientists have really gathered. Now, the star itself is a yellow dwarf, so it's bigger than a red dwarf, but really smaller than some of the really, really big stars, like the red giants and the yellow giants, the ones that just are about to burst with all of these elements and sorts. And as far as the diameter of the sun, as I have said time and time, yes, the sun is indeed big, with 865,000 miles in its diameter. Now, as far as really the composition of the sun, let's see. Think of the sun as a huge factory. Think of the sun as a huge factory. Because of that, we'll get to that in a moment. As far as the sun's composition itself, it's about, I'd say, 70% hydrogen, 28% helium, and 1.5% oxygen, nitrogen, and obviously you have your trace gases as well. Now, really, the sun is quite intricate when it comes to the structure of the star. On the top layer, you have your what's called the photosphere. That's where all of the, well, I say all, most of the solar reactions happen. Think of it as like the surface of the sun. Now here, this is just the tip of the iceberg when it comes to talking about how hot the sun is. For you see, on the photosphere, or really the surface, if you wish to call it that, it is 10,000 degrees Fahrenheit. That is really, really hot. Obviously. I'm really... No, I'm not joking. It's really hot. But anyhow, it gets hotter. For when you go down deeper into the sun, there's something called the convection zone. And here, the convection zone is about 3.6 million degrees Fahrenheit. But wait, I'm not done yet. When you get to the very, very center of the sun, past the convection zone, and past what's called the radioactive zone, where a lot of nuclear reactions happen, at the very core of the sun, it is over 27 million degrees Fahrenheit. It scares me just to think about it, I know. But when you really look at the sun, it does make sense. Because there are several solar phenomena, as I like to call them, that really happen. One of the major ones being the nuclear fusion of hydrogen atoms to make helium. See, when I said that the sun behaved like a factory, it really is kind of like a factory. For all of this hydrogen is actually being condensed down deeper and deeper into the core of the sun. And at that core, a process called nuclear fusion happens, where, take for example, 2 hydrogen atoms. See? Now, these 2 hydrogen atoms actually are fused together in this huge amount of pressure and heat to make a helium atom. And through this process, tons and tons of energy are exerted, contributing to more heat, more pressure, and really this whole cycle is really what keeps the sun running, so to speak. Now, with all of those processes happening within, there are some areas of the sun where it is cooler than the surface itself. And they are really signified by these little black spots that we have here. You see this? I drew this. I'm not a good drawer, but I do what I can. Now, these spots are called sunspots. And these spots are really about 2,000 degrees cooler than the regular surface of the sun. Now, let's see, where was I? There are some phenomena where it goes outside of the sun. Sometimes these hydrogen atoms really get agitated, so to say. And we form these things called solar flares and plasma blasts, which are really quite similar. You may have seen some solar flares. There's these huge arcing bits of hydrogen and helium that spew out of the surface of the sun. Some can go thousands of miles, some only a few feet. But all of these phenomena sort of encompass how massive and powerful the sun really is. Now, despite all this talk about massiveness and powerfulness, the sun is a huge help to our solar system. You see, the sun, this is a very, very interesting fact, by the way, it encompasses more than 99.9% of the whole mass of the solar system itself. Think about all the planets that we've talked about so far. This little heavenly body right here carries everyone. It helps the planets rotate around itself. It gives the planets night and day. It keeps the planets in order through its gravitational field. And, especially important to Earth's case, it provides the planets with solar energy. And especially for Earth, because we use that solar energy for life. But that is the sun in a nutshell, my friends. What a wonderful, wonderful, wonderful thing to have, yes? And you can look at it every day. I mean, if you look up at the sky right now, it's this big ball of yellow in a sea of blue. Well, let's see, where was I? Oh yes, we have a new segment on the show. Yes? Yes, we do. And that segment, my friends, is called Cortex Challenges. I got this idea from a few years of training camp that I've had back on Earth with, what's it called, NASA and SpaceX. And they would provide us with these sort of challenges to exercise our astronaut duties, so to say. And I have one for you today. Let's see what it is, shall we? Oh, yes. Aha! I see! Ha-ha! I've got an interesting one for you today. Now then, I'm sure many of you know my good little friend. His name is Jean-Bart Bear. He's obviously, as you all know, the chef on this little ship of mine. I need to really do some repairs on him. He's charging again, as you can see. He's been really quiet for the past few days. But anyhow, I challenge you to make your own little robot friend just as I have. Now, what I need for you to do, grab any sort of recyclable materials that you can find in your spaceship. Cardboard boxes, big or large, you know what I'm saying? Plastic bottles, bottle caps, springs, whatever you can really find that is recyclable or crafty. And using that big, intuitive imagination of yours, create your own little robot friend. Get out some crayons or markers or colored pencils. Rip out some paper, you know, get little designs on them. Stick them on your robot. Who knows? You might have a new little friend to keep you company. Now, obviously, your little robot won't be as complex as mine, for you see, this one is real. Look at all that metal, huh? Pure metal right there. Totally, yes. All right. But enough dilly-dally for now. Before you go about creating your little robot, I've got something else for you. And that is the next topic that we are going to discuss, provided by yours truly, the computer. And it looks like, my fellow space cadets, next time we will be discussing the inner asteroid belt. Really quite interesting place. As always with all the places that I talk about, yes. But I think that is almost enough for now. A big shout out to Anna for providing us with the question of the day. And as always, if you have a question that you would like to ask, please feel free to leave it down in the comments section. Who knows, your question might be featured on the next question of the day. But I think it is ta-ta for now, my fellow friends. Let's do our space salutes, as always, in 3, 2, 1.